So thanks everyone for coming to today's ARC Center of Excellence for Enabling Eco-Efficient Beneficiation of Minerals Signature Lecture Series. We're lucky enough to have Diana Drinkwater here from Metcelerate to talk to us today about training in mineral processing area. And I'd like to start by acknowledging the traditional custodians of country throughout Australia and their connection to land, sea, and community. And we pay our respects to their elders, past, present, and emerging, and extend that respect to all Aboriginal and Torres Strait Islanders peoples today. And with that, I'll just let Diana go ahead and tell us what her experience has been over many years, training a new generation of mineral processing people for the industry, and then we'll have time to discuss a little bit with her at the end. So thank you, Diana.
Thank you, George, and thanks for the opportunity to participate in this signature lecture series. I'm here to talk, as George said, about something that is close to my heart, and I'm sure is close to the hearts of many of you as well. And that is the need for us to ensure that we've got a secure supply of appropriately qualified new professionals to come into the industry that we're all working in and make the most of the opportunities that are here in front of us through this next phase of development. And I'm going to start by sharing something that I got very excited about when I saw it in the mining magazine. This is the editorial page on the of the August edition, August 2023 of the mining magazine. Apologies for the quality of the image, but we have a mining magazine with an editorial that's talking about how critical the mineral processing step is in the value chain. And when I say mineral processing, although my space, I guess, is mostly in the physical processing side of things, it obviously also includes hydrometallurgical and pyrometallurgical processing as well. The crux of the matter lies in processing, not extraction, is the byline there. And the third last paragraph, which is even worse quality resolution, I apologise, but listen to this. The significance of mineral processing cannot be overstated. While mining often captures the spotlight, it's the processing stage that unlocks the true economic benefits. And that's a message that we know is well understood. I'm sure every single person in this audience knows what I'm talking about and doesn't need this reinforcement. But it's a message that really needs to get out there to the broader community, because very often when people talk about critical minerals and mining, they think we're talking about the need to get exploration geologists and mining engineers skilled up to make the most. And we know that that's only a very small part of the whole story. So I'm very aware that the ARC Centre for Enabling Eco-Efficient Beneficiation of Minerals sees this as a really critical area of activity. And here's some words from your website where you talk about the key activities of your centre, and the 3 dot points you've listed to highlight the issues that you're dealing with are reducing water and energy use, increasing mineral recovery, and training a new generation, which is where I got the title for my talk. Without that, the rest is not going to have the impact that we need it to have. So I've got a couple of slides that are just reinforcing things I know you already know. You probably see slides like this at the start of nearly every presentation that people give these days. But it's really important to put things in context. We are talking about a global trend that is for increasing demand in a whole lot of minerals. And again, I'm not going to list out critical minerals for you because I'm sure you've been to many, many presentations where people have done it. In terms of training, we don't really need a detailed list. The key message is that there are a whole lot of other minerals that we haven't traditionally been paying a lot of attention to that are now front of mind with our industry. Increasing demand, and the graph that I'm showing you here comes from a US Department of Energy study where they talk about the increase in demand based on 3 different scenarios: the stated policies, the announced pledges, and the scenario required to achieve net zero by 2050. Even the most conservative one of those shows a really rapid increase in demand for the critical minerals that we're talking about. And just to reinforce that, here's a map of Australia listing out again the different commodities that are available. And the reason I've put this up here again is not to tell you something that I'm sure you already know, but to really reinforce the point that 10 or 20 years ago, Australia's primary mining focus was coal and iron ore, bit of aluminium, maybe some copper, and a few base metals operations and some gold. And when we think about the skill set required for our industry to deliver in that space, I'm sure there are still quite a number of skills, but it pales into insignificance when you compare it to the skill set required to address production of the sorts of critical minerals that are listed here. So we see many, many reports. Again, this is from an Australian publication, Commonwealth Critical Minerals Strategy 2023 to 2030. More skilled process engineers are needed due to the complexity of the extraction, refinement, quality control, environmental impact, supply chain, and regulatory requirements associated with meeting this increasing demand. So what are those technical challenges that we're going to be facing? And again, from a mineral processing point of view, this is just a bit of a summary. We're going to be dealing with operations with very low head grades in many cases, which means that the minerals that we're looking for are mixed up with many, many other kinds of minerals as well. We're also looking at an industry that has much more stringent product quality requirements than we've been accustomed to, particularly in the coal and iron ore side of the business. But even our copper and gold and base metals producers don't have to deal with the levels of tolerance that the critical minerals industry are looking for in terms of product quality requirements. And then on top of that, the mineralogy in which these minerals are occurring is much more complex than we're traditionally dealing with in many of our other operations. The target minerals that we're looking for are often associated with clays and other challenging material, which has all kinds of implications for process design. On top of that, we're having to grind these quite difficult materials down to very fine sizes to get the sort of liberation that we need. And that has implications in terms of materials handling, both dry with dust issues and wet when we think about the rheological implications of dealing with very fine slurries that have a lot of clay minerals in them. So there's a lot of complexity related just to those aspects of things. And then on top of that, the processes that are going to be in place to design these kinds of minerals are much more complex. So we're going to need smarter people, dare I say, than we needed just to deal with the coal and iron ore industry. And in order to deliver that, we've already got smart people. And I'm not suggesting that the coal and iron ore people don't have the capacity to develop skills, but the skill set needed there was a lot less broad than is going to be required to make the most of this opportunity. And I want to keep talking about making the most of an opportunity, not just being competent and managing not to break anything, if you like. I really think that we should be focusing on the skills requirements to ensure really high quality performance, very effective processing. So we need a lot of skills. Now, before I get too far into a discussion of what that means in real life, I've got to address this issue because we do constantly have people saying to us, well, it's all going to be automated soon, so why do we really need to worry about training people? And there are a number of studies that reinforce the fact that engineering in general, and particularly the sorts of engineering that you are all doing and are involved in, is not going to be fully automated for a long time. There will certainly be automation and digitization increasingly relevant in the discipline space that we're dealing in. But those solutions are going to need skilled people and appropriate technologies to deal with them. And in fact, there's going to be a whole new skill set that our technical people are going to have. And we may need multidisciplinary teams rather, to deal with that. But we're still going to be recruiting and developing engineers for quite some time to come. So there are a whole lot of skills required to meet the challenges, and really this slide doesn't say anything except there are a great diversity of things that people need to know, and that's what I want to talk a little bit about first. But I also want to talk about how the industry can assist with ensuring that these skills get developed. So we see this all the time. We hear organisations talking about how their people are their greatest asset. And if that's the case, then they need to be managing that asset in the most effective way possible. And that asset management needs to be tailored to the needs of the organisation itself or the industry that these people are working in, but also the needs of the people. Any development plan that we have to ensure skills and knowledge development needs to be meaningful for the young professional that is going through that process of development. So they have their own needs in terms of aims and objectives, career what they want to get out of their careers, and work-life balance and so on as well. So performance management of people needs to address all of those issues. When we think about the knowledge and skills that a mineral processor requires, there are two key questions that come out of the study of disciplines that really help us focus our minds on the skills that people need in order to meet any technical challenge. And so the question we ask ourselves is, what does a mineral processor do? And we can broaden that to include people involved in research as well as people involved in operations. And the other question that I really love is, how can you tell when they're doing it well? And that helps you really think about the sorts of things people need to know, but also the things they need to be able to do to make use of their knowledge. And out of that, we've done various studies that give us a list of things that mineral processing experts need to be able to do. And as you can see, there's a lot of technical stuff there. Now, there's a lot of diversity in this as well. For example, if you look on the left-hand side, one of the things people need to know about is laboratory tests and material characterization. Now, the specific tests that they need to know and understand are going to vary enormously depending on whether they're a smelter metallurgist working in copper or whether they're a flotation specialist working in base metals elsewhere, or whether they're dealing with a dense medium or magnetic separation process or any other process. So there's a lot of diversity in this. You can't just send everybody on a one-day course on laboratory test work and assume it's a one-size-fits-all. So it's quite a complex mix of things that people need to be able to do. So where does all this come from? In 2016, the International Mineral Processing Council ran an education symposium at their 2016 conference in Quebec City. And out of that, we put together a publication that's now available on the IMPC website with a whole lot of information about minerals industry education and training. And anyone who's interested can go in there and have a look at that. So that document has a number of different features. We had presentations from a number of our IMPC if you like, Advisory Council, international networks and others. And we also put together a document that we called the IMPC Mineral Processing Roadmap. And if you have a look at the document, I haven't got the accreditation in here, but there were a number of people involved in developing that document, and that's all itemized in the online publication, which, as I said, you can find on the IMPC website. I just want to share a few findings from that, because again, it's some very broad general things that play into the situation we're in today, where we're thinking about how we can make sure that we ensure that we continue developing the sorts of people that we need to be coming into our industry and taking it forward over the next few decades. So the IMPC Education Commission commissioned a survey, again in about 2016 or 17, where we talked to mineral processing specialists from a number of our member groups, and this is just a map of the world showing where people were, to get a feel for what was going on in minerals processing education and where the greatest needs were. So that's a list of the countries. And we asked a few questions. One of the things we asked were, what are the things that mineral processing engineers need to know? So the question specifically was, how important is it for a minerals engineer in your organisation to have competency in these areas? And when is it needed? And the when is it needed question, if you like, is really about what do they need to have when they're being employed, coming on board as new graduates, compared to what they can be expected to learn on the job. And if you look at the graduation, the light colours bars are the ones that represent what people can learn on the job. I put some ticks on the top 5 areas that graduates coming into a new job were expected to know something about. And it's no surprise in the minerals processing space that it's the technical stuff. Mineralogy, because, you know, if you're dealing with mineral processing, you need to understand something about minerals and how to interpret mineralogical data, which is just as important. And then obviously comminution and separation technologies get ticks, and there's a great tick there for sampling theory and practice, which we constantly see coming up as an area that needs to be focused on in training. Some of the other areas, although they're important, are not important in the eyes of the people that responded to these surveys on graduation. And what that means is that those are skills that people need to have a mechanism for developing later in their career, either on the job or in some kind of training activity. We also asked how well these topics are taught, because obviously the ones that we have ticked, again, the ticks for those ones that came up as most important, we'd really like to see that they're being taught extremely well in all our undergraduate institutions. Now, that's not the case, but we're also seeing that they're being taught well enough. I don't think we've got any real cause for concern here. So that was just a reflection from our group on what was needed in terms of technical topic development. What we have in the next slide are the other things that people need to know about. And interestingly, there was still a very strong focus, if you like, on technical STEM type topics. So basic science and mathematics was considered really important. Problem solving and critical thinking, which a good engineering degree in any area should be developing, but it was clearly seen as important. Not something that could be learned on the job, but important to bring into their jobs when they came in. So again, something interesting to think about, and there are some ticks here against the areas that were considered most important by our survey respondents. Another point I'd like to make, though, when talking about the data that came out of this survey, is that engineering degrees in mineral processing, or any other area for that matter, are not the same all around the world. And we asked people to send us information about the metallurgy or mineral processing degrees that the graduates in their part of the world were coming out with. And it's very difficult to quantify this sort of information, but we went through and tried to put them into 3 categories. And I don't think there's any surprises here. In Australia and Europe and South Africa, most of our metallurgy degrees, the ones that still survive, are very closely aligned with chemical engineering departments, if not actually part of a chemical engineering degree. We do see some of that in the USA, but we also see a lot of mineral processing metallurgy degrees that have survived there that have a strong materials engineering focus. And then we have other parts of the world where metallurgy and mineral processing are taught out of departments that have a very strong mining focus, which is interesting. I'm a University of Queensland graduate, and the department that I came through in the 1980s was mining and metallurgical engineering. And we did have a very strong mining industry focus in those days, which is very different from the UQ undergraduate program that's coming out now. So the point I'm really making here, and I'm going to go to the next slide and talk about length of degrees. The point is that just because you're employing a mineral processing graduate, you can't assume they've all got the same background in terms of their mineral processing capabilities. They're all going to know useful things, but the ones with a strong chemical engineering focus are going to have great process engineering skills, but they may not know much about breakage mechanics and handling particulate solids, things like that. The ones coming out of degrees with a strong mining and materials focus might not know as much as the others about thermodynamics, heat and mass balances, and so on. So there is quite a difference. And on top of that, some of them come out of very lengthy programs where they cover a lot of content, and others come out of shorter programs. And the India one, which shows up as 3 years, is not representative of all of India. There are 4-year programs in India as well. But again, I just want to illustrate the point that an undergraduate degree in metallurgy is not the same, you know, it can be very different from other undergraduate degrees. So what that's all about is the fact that becoming an expert mineral processor or metallurgist is not going to happen overnight. Nobody is going to come out of university and start work as a fully formed mineral processing engineering expert, no matter how good the university department that they're coming out of. Now, development to take that person from novice to expert used to be done, again, in my day, back in the 1970s and 80s, around the time I and my peers graduated. Companies traditionally put graduates into a graduate training program, which actually formally covered a whole lot of topic areas. And they all took responsibility for that. That no longer exists. There is certainly still graduate training going on in companies, but it's nothing like the sorts of training programs that were around in the past. So as my colleague Brian Flintoff says, this sentence down the bottom is his, the system has been broken for some time in terms of graduate development. Now, that doesn't mean we're not developing good graduates, but it happens far less reliably than it used to. And we can't blame universities. There are a whole lot of reasons why universities can't be expected to produce fully fledged metallurgical engineering graduates. First of all, they're shrinking. The universities are under a lot of pressure at the moment. They don't have access to the day-to-day mining operation, and they're providing fundamentals. They're not intended to provide a specialist metallurgical expertise. They're not in a position to stay up to date with the latest developments across all the areas that mineral processing covers. So it's a bit much to expect that of them. And on top of that, you've got the external factors we've got listed out here about how the industry itself is changing and the needs of the industry are changing themselves. So there's just a list of reasons here why we can't go back and point the finger at universities when we talk about the skills shortage in mineral processing. They're certainly absolutely essential for a starting point for skills development, but they're not going to be the whole story by themselves, and they never have been. This diagram makes a point very nicely. I've borrowed it from Brian Flintoff from Canada, now retired, but he's done a lot of space in the professional development area. And if you have a look, this is just a table of things that people might need to know in the mineral processing world. So you've got basic STEM type subjects on the bottom row, and then the middle row here talks about some of the specific mineral processing skills that are needed. But when we get to the top row, there's a dotted line through there, and the arrows are telling us that that top part is not necessarily something that you can expect people to learn at industry. At university. They nearly always need to develop that skill while they're in the workplace for all the reasons that I've talked about so far. Now, that dotted line moves up and down, and I would suggest it's actually moving down quite rapidly at the moment as the undergraduate degrees become less and less specialised and more generalised. So that means there's a real need for postgraduate opportunities to develop the skills that people really need if we want to be developing high quality mineral processes. So I'll just quickly go over this slide, sorry. It's tempting to therefore say, oh, but it's, you know, do we really need good education? It's expensive and it's difficult. But the argument here is that if we've got good information, good education, we develop an effective and efficient body of professionals, we're going to have happier people working in our industry, they're going to do a better job, and they're more likely to be able to innovate. And of course, the cost of poor education is the flip side of that, where we're just not getting the outcomes. So I want to talk a little bit about ways of developing those essential skills after graduation. And I've listed some of the things, if you remember the picture of the head with all the skills that were needed, could probably group those into a few main categories. So the core technical skills, obviously, if you're going to be working in flotation, you need to understand the science and the fundamentals of flotation, and the same applies in any other area. You also need to know knowledge of best practice, who's doing the best job and how are they doing it and how well is that comparing to what you're doing. And you need to be able to collect and manage data and make good decisions based on that data in any area that you're dealing with. So how do we go about making sure that we do that? There's been a lot of work done in mineral processing education, and there's a great report that was put out by Metallurgical Consultants in 2018, which you can find online if you go looking for it. And it talks about how difficult it is to develop the skills that people need. And it lists 3 reasons why it's not as simple as just coming up with a list of skills and setting up some training courses. The needs of the industry are changing rapidly. So we've got to be able to respond to that. And that means the training needs keep changing. Graduates themselves are changing. They're coming out of an increasingly complex higher education system. So their background and their expectations are changing. And on top of that, and related to that, are the fact that generational and population demographics are changing as well. So again, graduates have different expectations of their careers, about their work-life balance, about what they consider to be a worthwhile way to spend their work life, and so on. So all of that needs to be taken into account when thinking about how to develop the skill sets that we need. So I talked earlier about the need for organisations to be managing the development of their people so that they can make the most of that important asset that they're dealing with. And big companies in particular do have centrally managed human resources-based training. The issue that we have is that the technical sorts of skills that we've talked about here are actually quite complex. And it's very difficult for human resources departments to really structure a program to ensure all those skills are developed. So the HR managed training is fabulous in developing leadership and teamwork, management skills, cultural awareness, diversity and inclusion training, and so on and so forth. And that is critically important to operating as a professional in the 21st century. However, without the technical skill set that underpins that, the mineral processors and metallurgists working in our organisations are still not going to be doing a great job in terms of generating value for their organisation. And again, it's very difficult for HR departments to manage that. So normally they will outsource that to technical people within the organisation because they have a better way of managing that. So again, before I leap too far into discussing more detail on that, let's talk about how much it really matters whether metallurgists are in a position to make good mineral processing decisions. My argument is, yes, it's absolutely critical, because if we want to generate cash flow in a mineral processing operation, then we need to make sure that we are operating with the best feed into our processes, that we run for as many hours as possible, that the concentrates that we're producing, or the final products, if it's a metal production area, are high quality. Sorry, I've got to turn the sound off here. The tonnes per operating hour, in other words, throughput through the plants, is maximised and costs are minimised. So I just put my phone on silent. So good metallurgical decision making is absolutely critical in that case. We need competent professionals that are able to do that. So there's lots of spaces, apart from head grade, which we have little control over in mineral processing. There's lots of opportunities for us to be impacting on all those other elements that contribute to revenue generation. So that means we need to develop the skills in our young people, and there are a number of different ways of doing that. So this slide here just lists how that might be done. HR departments have some responsibility for coordinating this, but they do it in many different ways. And the diagram here shows that, you know, we can have in-house company-based programs, and they can be off-site, like an in-house training school. There are summer schools and winter schools at a number of universities all around the world that do this kind of training, or they can sometimes organise bespoke in-house development programs. These things are usually very disruptive from an organisational point of view, because you've got to move people from place to place. You've got to take them out of the workplace, even for the in-company programs. And then we have online and other kinds of less structured industry-wide organisations. And again, those are fairly disruptive, but of course the online option is the one that is most appealing in terms of minimising the impact on an organisation. So the challenge is then how to develop that kind of training in a way that still delivers really good educational outcomes. So I want to now talk a little about the journey to becoming a mineral processing expert, because it's not just about delivering training programs. Most of our mineral processing experts took quite some time to become experts. They certainly didn't arrive on their first job site as a guru in whatever area that they were in. So a whole lot of things need to happen between that first day of employment and becoming an expert. And usually a lot of other people are involved in that process. So when we're looking at programs to help develop people, we actually want to be thinking about how those programs are integrated into the workplace to allow the best learning experience outcomes. Now, there's a diagram here, it's called the Dalton-Thompson model, again, of the journey from novice to expert. But it's focusing here on how those individuals at different stages of their journey are giving back to their own organisations. So in this case here, we've got the novice, the Luke Skywalker on Tatooine, basically just doing what he's told, contributing in a way that's really dependent on others giving him direction. As we move into the Qui-Gon Jinn stage, we can be making individual contributions fairly independently, but that person is slowly moving to an area where they're also going to be running sections of an organisation and ensuring that their contribution actually takes place through others. So during that stage 2, stage 3 process, we want our developing mineral processing expert to be also developing their coaching and mentoring skills. And then eventually, with time and practice, you know, we have Yoda, who doesn't go out and do a lot, but makes a massive contribution in terms of his vision and his strategic impact on others. So coaching and mentoring is also an important part of development. And in fact, the days of mineral processing in-house professional development, the graduate training programs that I and my peers were often exposed to, usually involved a number of senior engineering professionals who spent quite a lot of their time we thought giving us a really difficult time, but in hindsight, we've realised focusing on developing our skills. Now, in order to have that process work well, obviously it has to work for both partners. The young professional, who's the one receiving most of the coaching, needs to feel supported. They're at a stage of their career where they're absolutely terrified that they might break something, you know, or they might show people how little they know. So they need to be in a safe environment where they can try things out, develop their skills and learn some confidence in a supported way. The senior partner, the point I didn't make when I was talking about that development journey, is that it's the people in the middle of the journey who are the busiest. Not only are they absolutely frantic at work, but they're generally very busy in their home lives as well. So these are people that don't have time to waste. They're focused on their own career development, as well as their job performance. So they want to make sure that anything that they're spending a lot of time on is going to be worthwhile in terms of their own career and their own development journey, as well as their ability to do their jobs. So it's just something I'm putting out there, because when we are developing young people in any situation in the industry, both in operations, but also in the research environment where I know a lot of you are working, then we need to ensure that our development processes allow for these kinds of developments, as well as just people filling up their heads with knowledge and learning new skills. So I want to talk now briefly about a program that we put together, not because I think everybody should rush out and say this is the answer, but it's an example of one way that we tackle this quite challenging problem. And the program is called Metcelerate. This is where you see the name of the company that I'm working for. And we kicked off this program with support from 3 companies, Newmont, Freeport, McMoran and Teck, who were all driven by the sorts of things that we've been talking about, the need for good, sound mineral processing education, and the difficulty in delivering it in a meaningful way. That we were finding that a lot of the company courses that were being developed were ad hoc, not particularly well integrated into what was going on into the workplace, and that there was a need to do something a little more systematic. So we sat down in 2019 with representatives from all 3 of these companies. And I see Renelle Katz is here. Renelle was very much part of this process going back to 2019. And we mapped out a program that would meet the development needs in the mineral processing space. So again, apologies to the hydro and pyrometallurgists in the audience, but the model would apply in any area. So we came to an agreement about what topics needed to be covered. And you can see the topics here. We started off with some technical foundations, but before we got into that, we had a very brief introductory course to talk about where the value is generated in mineral processing. It was felt important that that was there as a starting point. And then from there, we moved into the technical areas of mineralogy, comminution, flotation. If you think about those graphs I showed a little while ago, there they all are. We do have a very brief module on hydrometallurgy, because even mineral processors who aren't working in that space need to know something about the chemical nature of leaching and so on, because there's more and more focus on having byproducts coming out of operations. There is an expectation that people have a little understanding of that. And we capped the whole thing off with an experimental design and project course. So we have an online program. The 2023 schedule is down there in the bottom. You can see it runs for almost 2 years. It actually finishes just shy of 2 years, but the stragglers might take all of that time to finish. And it covers all of these topics. So we're running that program online, and we have participants at the moment. We put over 180 through. We have a current group of 90, and the year that's ahead of them, but just finishing off, has about 45 in it. So all up, we've put about 180 through this program. And you can see they're all over the globe. The program allows itself to be delivered in all of those locations. The team, and I'm only one of 3 core members of the team that put the program together, looks like this: myself, Bob Sykes, who is based in the United States, and Professor Jan Cilliers, who's at Imperial College in London, are the core team that put this program together. But we very quickly pulled in some administrative support, which we have here. And again, we then, about 2 years ago, translated a lot of our content into Spanish. So we have a team based in Chile who are also supporting the program and running a version of it out of Santiago in Chile. But we don't do the teaching. When we did our original design, one of the first questions we asked was, who's teaching this stuff already and who's doing a good job? You know, where are you finding the best online or the best courses? And we then negotiated with people that were delivering those courses and came up with some arrangements. We did get funding from all of our sponsors, so we were able to pay for the development of this content and pay to have permission to use it in our online focus. So we're not reinventing the wheel. We're not trying to teach stuff that other people are already doing a good job of. We've actually gone to the people that are doing that and asking them to teach into our program. And again, that's a model that will translate very well elsewhere. But we also addressed this issue of really reinforcing the learning by ensuring that the participants in the program are thinking about how to apply what they're learning on the job. So that means they need someone within their workplace to help them talk about how what they're learning fits into their day jobs. And so we ask all participants or the companies to nominate a mentor for each participant, so that that person has someone within their own company that they can go and talk to. This becomes especially important at the end of the course when they're being expected to run a project, because obviously they need employer support if they're going to be able to do worthwhile projects in the workplace. So that's Metcelerate, but it's just one way of ensuring that online development is available in a way that can really add value, much more than the ad hoc sorts of short courses that we see in most situations. But it's only one way, and sadly, we're not going to solve the skills shortage problem all by ourselves, no matter how many people we get into our program, because there are a lot of other kind of skills that people need, and there are other ways of doing it. But the reason I do like to tell people about it is that we are, I think, doing something that's quite unique in terms of delivering a program that meets the needs of our industry, using online technology, using the sorts of things that are available in the 21st century for delivery. So I want to conclude by saying this is not a wicked problem. I'm sure you've heard people talk about wicked problems and saying, you know, various things are really, really hard to solve. Training is not that hard to solve. It's a complex problem, but there are fairly straightforward solutions. The issue is that they're not going to fall out of the ground. They need somebody to actually bite the bullet and spend some money and put some serious resources into development. And so we were very fortunate, as I said, that in 2019 and 20, we were able to get significant funding to build a high quality program that is immediately starting to deliver results. It's certainly a work in progress. I'm not suggesting it's perfect. We're still working very hard to learn from our experience so far and keep improving the program. But it's not going to be done overnight. It really does cost money, and somebody's got to stump up the money up front. You can't just expect people to build it and then maybe, if they're lucky, make money out of it in the long run. But the benefits easily outweigh the costs. So that concludes what I want to talk about today, and I'd be very happy to answer any questions that people might have and talk a little more about this topic if anybody wants to make some comments. Yeah. Thank you for your time.
Thank you very much, Diana. That was fantastic. Much appreciated. We do have plenty of time for some talks, so either just unmute yourself or something in the chat if you want. I jotted down a few questions along the way, but it turns out you came back and addressed most of them, which was just saying I was looking forward to what you're going to say. One of them, though, was about, you mentioned engineering judgment as an important skill. And certainly that's one of the things which you can't teach at university. You need to go through that process of working with a mentor and making mistakes and then learning from that. And you know, as you progress through your career. So I guess that's where the role of the mentor is, to allow the person a bit of flexibility, but not that they're gonna waste $10 million somewhere.
Yeah, and in a non-threatening way, so that the
Yeah.
person does feel that they can safely make those mistakes. I guess but one thing about engineering judgment that can be done at university to some degree is providing open-ended problems. So again, in mineral processing, we often have a plant design course, so that there's some engineering judgment required in those sorts of courses. If they've done any kind of an honours thesis, maybe they get the opportunity. But you're right, the workplace is where that skill really develops. And it's so important, isn't it? They're often terrified in their early careers about making big decisions that they know will have impacts. But they need to be, you know, we all went through that ourselves, I'm sure. I have a friend who calls it the whites of the eyes stage of career development, when they're absolutely terrified to make if you like, make decisions because of the risk that they might get something wrong.
I mean, the students, we do include those open-ended engineering design, you know, kinds of tasks for students. They hate it at first.
Yeah, they
want to know
absolutely do.
They want to know the number is 57.83. They don't want to know there's a number of different good ways of solving the problem.
I know, and I've been through that myself as well. No, they absolutely hate it, but it's just something that they've got to get through. There's always someone who's happy to just go rushing out and make choices. But you're right, 90% of them really hate that risk. And again, it comes back down to the fear that they're going to get something wrong. So it's a development stage, and I guess that's why it is important to ensure they feel supported when they're going through those sorts of things.
Thank you, Andrea. Thank you. What time is it there?
It's almost 7 p.m.
Okay, not that late. Okay. Thanks for joining. Yeah.
Thanks. An excellent presentation, Diana. Like really, really good. I'm going to be encouraging some of my team to review this after. When you were going through those initial studies and everything, what we're seeing is a definite lack of older people like my age being able to mentor and to teach many of the young people coming in. And so they're learning things. Well, they're not necessarily learning everything that we learned when we were coming through. They're learning a portion of the story. And so I'm just wondering what your thoughts about that are. And do you think that your courses are hitting that part, that they're not catching, or your thoughts?
Oh, yeah, no, that's very much something that people do talk about. People don't know what they don't know, and even their supervisors don't know what they don't know. We do keep talking about knowledge of best practice being important, and this is all wrapped up with that. Part of our thinking with the design of this program is that the mentors, the senior people who are, if you like, supporting and leading the young participants, also have full access to all the course material. And we have some very high quality course material in there. As you see, we've asked industry experts to give us stuff. Some of it is well beyond the needs, if you like, of the early career participant. But it's there in case, well, for a number of reasons. They can come back and look at it themselves, but it means the mentors also have the opportunity to look at that. So they sometimes talk about Trojan horse learning, where you're sneaking a bit of extra education into a program. We don't want the mentors to feel threatened that they're being asked questions they won't be able to answer. So we actually made the decision very early that the mentors would have full access to all the course material anytime they want. But we also we run live tutorials with the course leaders, and the tutorials are focused on, so we have assignments that people have to do, and they're real assignments. They have to write something and submit it. It's not a sort of click and flick thing. And so the course leaders often focus on topics that are quite high level, and again, focused on, if you like, best practice type activities. We really try and keep an operational focus. So again, if you are developing a similar program in a different area, if you think about what you'd be doing in tutorials, what you can do in, if you like, real life engagement opportunities, to really bring people up to speed on what current best practice is, and what sort of tools or methodologies are out there that they might not have seen. That's a great way of sneaking it into the organisation.
That's awesome. Thank you so much.
Thank you. Who's the next? Hello, GKE. Who's that?
Oh, I think that's me, George. It's Ellen here
Is
from
that Ellen?
Deakin.
Okay, thank you.
Hello. That was a really excellent presentation. Thank you so much. My question is around teamwork. This is something that we really sort of struggle to actively teach, at least at my university. And I'm wondering if you had any perspectives on how we can better teach teamwork skills and help our kind of graduate engineers to be better prepared to work with diverse teams in the workplace.
Yeah, I've got two things to say about that. First of all, we're very careful with Metcelerate not to tread on the toes of human resources departments, who often have those kinds of programs already in place. So we don't want to be pretending, that we can do teamwork and leadership training better than HR specialists who, that's their bread and butter. So we don't, if you like, do teamwork training specifically. However, we all know that social constructivism is a thing. People learn better in groups than by themselves. And we encourage them to do their projects and even their assignments in groups. If they're on a site with several people and all doing the course together, we encourage them to work together. Now, there's always a bit of criticism about that from people going, oh, they'll, one person will do all the work and everyone will copy. But we kind of figure this is adult learning, and no, we expect them to organise themselves. We do sort of look over their shoulders to try and see how things are going, but we're fairly fluid in accepting group submissions, because if they're talking to one another about the task that they're working on together, even if individuals don't do that much work, they're actually going to learn more by talking about the big picture that relates to the task that they're trying to achieve. So we do encourage teamwork. We get resistance from the individuals themselves as well sometimes, because they're straight out of university where, they feel like it's cheating if you're not doing all the work yourself. And yet teamwork is all about saying, well, you don't have to do all the work yourselves. In fact, you can get better outcomes by working smart with other people. I'm not trying to say we've got it right, but you're absolutely right to raise it as a really important part. And look, just one other thing we do in our assignments. For example, we in our flotation course, we ask them in their first assignment to report on some aspects of how their flotation operation is running. And we tell them, go and talk to the plant operators, talk to the maintenance department, list out, the issues that they think are most important. So again, we do try to encourage them to be thinking about bouncing off others when they're dealing with things.
Thank you. No, that's really helpful to hear your perspective on that. Thanks.
Anthony.
Hey, Diana, thank you for a very interesting talk. One of the things that was highlighted in your survey was the need for graduates to have computer skills but particular programming abilities. We've had the same discussion, I think, several times with IAG and the industry advisory group in the department, and they say very similar things, that the graduates don't know how to use this program or this program. we've found it difficult to include that sort of thing into the course, other than simpler things like MATLAB or Excel skills, or but maybe HYSYS, and but more complex programs are going to change from company to company and all the rest of it. So how do we get that balance right?
Yeah, it's a great question, and you're absolutely right. You could, whatever's currently in use now, you can make sure everybody comes out of university using that, and in 5 years' time, it'll be irrelevant, and there's something else that they need to know how to use. So my view is that they need the foundational skills, I suppose you could say, to ensure that they've got the ability to pick up new software. We actually deliberately stayed away in Metcelerate from providing training in any specific packages. We talk a lot about the importance of using analytical tools and modeling and simulation, but we don't teach. We say, if you want to learn simulation, go and talk to the people that, that sell those packages and run those training courses as a business. So we try and talk generically. We talk about white box, grey box, black box models, but then we say, go off and do a training course from, JK Mollycock Tools, something like that, if you want to learn some of those specific modelling skills. It's a tough one. And I think the individuals and the companies really need to be, I guess, handling that side of things.
I'm glad you say that, because that was our response. Was no.
Well, universities can't be expected to do it. No, it's crazy. It's like expecting them to be at the cutting edge of every different technology that's covered. You don't have enough academic staff members to do that. So, yeah, I think sometimes human resources departments put a bit too much back. I've had human resources people say to me more than once, how can we get universities to, fix this? And they've never, ever produced someone with the entire skill set that's needed. That's not the job of universities.
I think that the challenge is that if we bring more, and we are bringing more digitization and computer skills and how to use AI into our teaching, but it means that something else is going to be less.
Got to fall out.
And that's where it's good to know what the critical things are, right? And that maybe some of the hydro and pyro and other things can be taught in less detail and left to be learned on the job.
Yeah.
Yeah,
it is. It's a juggling act, isn't it, to fit everything in? Particularly as they're coming into first year with, much lower skills in, say, chemistry and mathematics than they had back in the old days.
yeah.
So,
There's a comment here from Subhashish. The slide showing the mining mineral. Do you want to just comment, Subhashish, or do you want me to read it?
Yeah, no, I'll spare you that, George.
Yeah, go ahead. Yeah, thanks.
Nice presentation, Dana. I think I enjoyed your presentation during a presentation in Cape Town as well. Just had a bit of time to look into that slide about the Indian perspective in the mineral processing. So historically in India, the mining, minerals, and metallurgy were offered by the separate departments, and they were never mixed up. Obviously, chemical engineering has their identity completely separate, never got mixed up into all of this. And some of this mining engineering program, I found two of the programs are nearly 100 years old. They're Indian School of Mines and Indian Institute of Technology, Varanasi, BHU, that is called. They're around probably 90 years they're running this program. So yes, and there is a lot of variation as well. Like undergrad programs are of typically 4 years. You mentioned 3 years, but 3 years usually the master degree program, but it could be 2 years as well. And then there are dual degree programs which give you combined bachelor and master degree, which could be 5 years. So there's a lot of variations in the duration of the programs that are offered. So you might just want to sort of include that
Yes,
information. in
and
the
look,
slide, maybe.
you're absolutely right. And I know we also have numbers, so I probably should remove that slide and replace it with something else, because I'm aware there are a lot of very, very high quality programs coming out of India. And in fact, there's 3-year programs, as I say. A number of Australian metallurgists will come out of a science degree background and be employed as metallurgists just because of the really small numbers of people with the right skill sets. So perhaps I should change that slide so that it doesn't give the wrong impression.
No worries.
The other interesting thing we collected data on is numbers. And in fact, India is producing quite significant numbers of mineral processing professionals who are all being employed around the world. So it is pretty significant.
There has been a very like distinct emphasis on this mining and mineral processing metallurgy separate to chemical engineering. So we used to say that the chemical, we as a chemical engineers, we never did the solid stuff much. We were restricted to liquid and gas only, and left the solid stuff to the mining and mineral processing engineers. Anyway, thank you so much, Dan.
Okay, thanks.
Thank you. Yeah, let's just thank Diana again for a very fascinating and stimulating talk. We can about training, and we're all a part of that, a big part of that. Thank you very much.